Welcome back, and today we're going to talk about some rather strange goings on in my kitchen. So one of the strange things about being a physicist is you notice things around the place and you're always asking yourself, why did that happen? And you use the skills you've learned elsewhere to try and explain things that are new to you. And what was happening was I was putting the plates away after doing the washing up, and when I put them in the cupboard, this happened. So I rushed for the video camera, as I normally do in these situations, and took a bit of film. And to repeat what actually happened was I took the bowl and I put it down on the plate, and then I noticed it was rocking like that. And it seemed to go on for ages. But what was stranger was when I tried to stop it from rocking. Now, I'm not sure how well that comes out on camera, but if you put your finger on it to try and slow it down, the rocking actually increases in frequency, which is rather weird. So this got me thinking, and I thought, I've seen this before, but I've never quite seen it in the same way. You might have noticed that if you take a coin or something and you spin it on a flat surface, it does a similar sort of thing. It wriggles from side to side as well as rotating. And what we saw with the bowl was just a wriggling from side to side, but the frequency did go up when I pressed down on it and reduced the amplitude of the oscillation. And that reminded me of a lovely piece of physics kit that I'd like to show you now. So there was a chap a while back who'd seen this experiment and he thought, let's scale it up. So he made himself a much bigger coin and got a much better mirrored surface that was slightly concave. And when he'd finished designing it, it was called Euler's disk. He named it after a mathematician who'd done some of the mathematics of this much before he actually built this piece of apparatus. And you can buy these on the internet, and what you get is your mirrored surface that's slightly concave and a great big coin to spin on the surface. So let's have a play with Euler's disk. So if you've not seen one of these before, you're really going to like this. I'm going to take the big coin and the mirrored surface and put the coin on the mirror and then just give it a spin and let go. Now, this is what I was reminded of when I was looking at the bowl rocking from side to side in the cupboard. Very low friction, so it's losing energy to the environment very slowly. And the frequency of the oscillation, just like the bowl and the coin, goes up and up and up. Now, forgive me if you think I'm going to spoil things by speeding it up a little bit, but let's put a little bit of weight on the centre. Isn't that fantastic? So let's have a closer look at what's going on here. One of the things I need to do is to draw a line on the disc so you can see whether it's rotating or not. So I'm going to put a bit of sellotape on it because I actually don't want to get ink on the metal of the disc itself, and it'll be difficult to get it off. So I'm going to do it on a piece of sellotape. There we go. Let's draw an arrow on there. And we'll get it going again. And I think you'll be quite surprised by what actually happens if you watch the arrow. Right, let's get it spinning up again. And it's a little bit difficult to follow to begin with, but see if you can see what the arrow's actually doing as this thing spins down. So you'll notice that the arrow's going round and round, and it's taking 1, 2, 3, 4, 5 rotations. You can feel those as you go along. But the shaking oscillation is at a much higher frequency. And the best way to show you that is just to put a bit of weight on the middle. Look at the arrow and listen to how many times it's vibrating from side to side. There we go. And there's no trick photography there at all. It's actually rotating with quite a low angular velocity, but it was oscillating from side to side with a very high frequency indeed. And that's what gives it its characteristic sound. So that's the joy of physics. I don't think I've discovered something radically new in the kitchen, but I used the physics that I knew from the Euler's disc toy to try and explain what was going on with the plate and the bowl. Though I find it really interesting that with the plate and the bowl, you only get a rocking motion, you don't get the rotating motion happening at the same time. Anyway, Euler's disc is a fantastic toy. I've loved playing with it, and perhaps it's something you should get yourselves, because I can play with this for hours and hours, and there is some good mathematics that goes with it, but I'll leave you to sort that out. So I hope you enjoyed that video. What I'll do after the credits have run is I'll leave a film of the Euler's disc running right from start to finish without me messing around with it. Anyway, do another video soon, and I look forward to seeing you then.